Joyce. First of all, your homework online is up to date for section 10.1, 10.2 eventually, and 10.3 and 10.4. But power series, we're going to try and finish today. It's going to get exciting. It's going to be an adventure. Why was it already exciting on Friday? Sadly, no one remembered. That's kind of Debbie Downer. But what did we see on Friday? How did we start class?
Like that, really. We review power geo series.
Nope.
Oh, the
Graphing calculators, because I couldn't get my thingy to work, remember?
Oh.
What did I have them graph, or what did I have you graph?
It's like 1 and then 1 over 1 x plus 1.
Yeah.
Yeah, I had them graph this, and it doesn't really make sense unless you're watching the video. But I had you graph 1 over x. I think it was 1 over x. So he's hidden. He's hidden beneath the yellow thing. I had them graph 1 over x, and then what did I have you graph next?
Like 1.
1, and then what?
1 plus x.
1 plus x, and then
1 plus x squared.
1 plus x squared, and then
And plus x.
1 plus x squared plus x cubed, and then et cetera, et cetera, et cetera. And what did you guys notice going on in this little interval from 1 to negative 1?
It got closer to 1 over 1 minus x.
You got closer and closer and closer to 1 over 1 minus x. And that was pretty spiffy. And then we saw something else. We saw if you do long division. Where's my long division? Ah. If you do long division backwards, although it's really forwards.
That blew my mind.
I'm watching.
Okay. If you put the 1 in the box, usually we would say like, hey, nothing goes in. So if we go ahead and say, hey, wait, 1 goes into 1 time, right?
Yeah.
And we go ahead and subtract, and then we say, oh, 1 goes into x times, and then 1 goes into x squared times, and oh my goodness, what is this? The same thing as the infinite sum. It's not exactly a polynomial. We can't just say it's just a polynomial, just like we can't say an infinite series is just a sum. But we can say it is the sum of polynomials, or of monomials, I would say it better. However, does it converge for all x values? No, it only converges on the interval of convergence. And how do we figure out what the interval of convergence was? We saw it on the graph. We saw it between negative 1 and 1.
You put r in between negative 1 and 1, and you solve for.
Why r? Because what could this be seen as?
Geoseries.
A geoseries where r is equal to
X.
x. So if we multiply by x again, and then by x again, et cetera, et cetera, et cetera, et cetera, we can see, hey, this is a geoseries, and the geoseries has a sum of a sub 1, which is 1, all over 1 minus r, which is 1 minus x. However, that's only going to converge when r, who is x, is in between 1 and negative 1. Haha! Okay. So that was kind of a long story short. We got to define what, oops, there we go. Define what power series are.
How does that help us with power? It just defines it.
It basically defines it. It gives us a basis to start from.
Kind of just,
So a power series is a series of powers. What? A series of powers. X to the 0, x to the 1, x to the 2, x to the 3, etc., etc.,
What
etc.
is P series times?
I was hoping the powers would be
P series.
P, you can think of it as it is a power because it's x to the power, x to the n. But it's different. It's different than when you hear power series. That's why I think it's called P series and not power series. Because power series is specifically talking about the sum of x's raised to certain powers, not like a 1 over with the P series test. Does that make sense? So they both mean powers in the same sense, x raised to powers, but in different contexts. Kiddos, do you remember why we talked about the difference between centered at 0 and centered at A?
Because it's slightly different.
The formulas are different.
That's where the x is within negative 1 or whatever the center is.
Yeah, wherever the center is, the interval of convergence will go off of that. So say we wanted it to be really, really close by 0. Okay, cool. Centered at 0 is sufficient. But what if we want really, really close somewhere else, like around 4? Well, we better center it at 4, and that way we can have it converging around where we need it to converge.
Left is plus, right? It's shift left if it's plus.
If you look at this one, the x equals positive A. So x minus A, if you see x minus 3, then it's centered at positive 3. Yeah. Let's not stress about that too much more. Okay. Where did we leave off? We did some division-y things because we were trying to find the power series using division. I think at the end of Friday I was like, hey, there has to be a better way than division, right? Cool. The better way than division is where we are here.
There has to be a better way.
All right, here we go. Picking up in notes. Someone let Georgie know how many spaces, pages.
I do, but I was gonna take them when I got home, because that way I can. You what?
Okay. So you're gonna be super focused now.
Yes.
Find a power series 4. Wait a minute, guys. Is this the same or different than the one that we were doing like all day Friday?
Different.
Different. But what did I put first? Who is this guy?
The first one.
The first one. And once again, how do we know who he is? Well, remember, isn't he just a geometric series because he fits my a sub 1 all over 1 minus r? Right? Where my a sub 1 is 1, where my r is x, and so I can make my geometric series just realizing that he's the infinite sum as long as it converges. Are we okay? Okay. Now, what did I do in step 2? Step 1, I started with who I know. In step 2, what did I do? I said, wait, I need it to be this instead, so who did I plug in instead of x?
Negative x.
Because minus a negative x is plus x, right?
Yeah.
This entire section is lots of baby puzzles, and it's going to get exciting trying to solve them. But in this one, it's the easy one, because how do I make it 1 plus x? Well, I subtract a negative x. So what am I going to plug in all the x spots?
Negative x.
Of cow.
And what happens when I plug in a negative x to even and odd powers? The odd powers need to flip, and the even powers are going to remain the same. I have the first 4 non-zero terms. Question, kiddos, in order to actually complete this example, what else do I need to put? Not plus C. It says include the first 4 non-zero terms and the
General term.
general term. What's the general term?
1 over 1 plus 1.
That would be the final what the entire series equals, which is this guy, right? The nth term. What would the nth term be? Negative 1 raised to, am I going to start at 1? Sam. I don't want to do n, right? Because if I raise negative 1 to the 1, shouldn't that be negative to start with? So how am I going to fix that?
N plus.
Sure, we can do n plus 1 or n minus 1. Either one will work. We just need it to not start at a negative. And then, can I put x to the n? Oh, but do I start with an x? Remember, this has to work for the first term, and so a sub 1 according to this would be negative 1 squared, which is good, positive, but x to the 1 is not there, right? Exactly, so I can do n minus 1 to take away the first power. That
Can't
would
you
be
just start at 0?
We could if we were making a series out of it, but I didn't make a series out of it. You know what I mean? So if I make a series, I could set the bottom bound to be 0 and the top bound to be n, but we'll assume. Thinking about geometric series and how we have a sub 1, right? We're just keeping within the same notation.
Well, that is a series. Right? So.
No, it converges for x between 1 and negative 1.
No, I mean, like, if it had a series in front of it, it's alternating series, but alternating series doesn't diverge. Its limit is not 0.
Depends on the interval of convergence, right? Depends what x equals.
Oh, I see what you're saying.
Because if 1/2 was being squared and then cubed, etc., then it would be approaching 0, true? So let's talk about that, because technically, didn't we skip part of what they asked us to do? Find interval of convergence. How do we find the interval of convergence? IOC.
What's R?
What's R? Negative x, right? Can't we set negative x in between negative 1 and 1? If we solve, we multiply everybody by a negative. What's going to happen to all my inequalities?
You take it 1 negative.
Yeah, they're all going to flip, but you're still going to have interval of convergence. X is still going to be within negative 1 to 1. So, whoa, is that like the interval of convergence for everybody? Nope. Let's try example 4.
It'd be cool if it was, though. Make my life, our lives, significantly easier.
So long story short, at the end of the day, it would make our lives easier, but sadly it's not the case.
Long story short, life sucks.
What? How
Who
does
said
that just
that?
happen?
Who just said something like that?
3-day weekend was supposed to help our outlook on life. Anyway, so. Example number 4. Find a power series that represents x over 1 plus x. Well, what do you think we're going to do now?
Oh, this one.
If this was a separate problem, what would we do? We would start here. Why? Well, we know him. Who is he?
1 plus x squared.
And we would say, okay, let's make it 1 minus negative x. But hold on, haven't we already figured out who this guy is?
Yeah.
Isn't he just the same thing but alternating? Okay, so how do we do step 3? How do we get to the actual guy we're trying to find in this example?
I mean, you could always do use of.
No, not you said. It's not that hard. Look at the polynomial. How do we go from here to here?
Multiplied by x.
Multiplied by x.
Your genie command.
So it's going to be x minus x squared plus x cubed minus x to the 4th. Right? We could still theoretically have our negative 1 to the n plus 1 from up above when we're doing our general term. But what's going to be the x power now? What's our interval of convergence?
Just ought to be equal to that thing. Right?
How do we do the interval of convergence? We still have the negative x thing, right? If we want a negative 1.
Should we put x over negative x between negative 1 and 1?
Well, r is just going to be x, right? Or negative x, I should say. Wouldn't it be the same thing?
Would it be?
Because if r is negative x,
Could we rewrite this to be
wait, what? How did we do that?
how did I do that? How did I go from the top to the bottom? Multiply everything by 1 over x. Wait a minute, why is that helpful?
Well, how does that make the 1 stay 1 over x? Oh, I see.
Huh. So who could I say my R is? So for my IOC, I set negative 1 over x. Right?
So you have to flip everything.
Which is still
Yeah. Flip everything so I'm still good on this score, right? Divide by a negative everything, flip all the signs, and I still have x's within negative 1 to 1?
Yep.
Well, that was not very exciting, but true.
All that work for the same result?
Oh, this one. Okay, does it get any more exciting than this?
Depends on your definition of exciting, actually. Oh.
Oh, you missed it. It was raining really hard in here, and so then the ceiling started bubbling, but I didn't notice it in this class. You kind of see it did that, how it's all bubbled. Because the water leaks down from the patio up above, something about like where the door meets the patio, it drips through, I don't know. So it was dripping through that, and then it started dripping on calculus kids during the test in period 6 on Friday. And then they kind of moved, and then it started dripping more, and then Jose came in after school and stuck a knife in it, and then like the water was pouring out through the knife hole.
That's awesome.
It wasn't like exploding that was pouring out pretty suddenly. And then he started to try to like take it down to dry it out, and then the whole thing just crumbled.
Ooh.
Put it into the
Wow.
and now I have a whole thing.
Nice.
Go team! Anyway,
Somebody up there?
what?
You can hide somebody up there?
I'm not so sure it's strong enough to hold anybody that's not like a 2-year-old.
You can stick Lucy up there.
I mean, have you seen The Office?
Yeah, that's what I was thinking, Amanda. That's exactly what I was thinking, Amanda.
Wait, how do you do example number 5? Joyce, there's a hole in the ceiling. Check it out. Actually, you already know about the trick. Anyway, what do we do?
Turn up.
Who should we start with?
You
Whatever one.
Yeah, I like it.
her.
How do I get to what I want it to be, which is 1 minus x squared?
Minus x squared in parentheses.
Now what?
Yeah, minus.
1
Right? Plug it in, plug it in. What's going to be my next term? Next term. Right? Because power to a power you multiply, so you only have x cubed, x squared cubed is x to the 6th, etc. Wow, it just got cold in here.
Yeah.
That's intense. We'll see if it turns off. What would be my nth term, cool kids?
1 x to the 2n.
Almost, except we're starting at 1.
It's minus
Minus
1.
But that's going to be odd numbers.
Minus 2.
There you go.
So
Because 2 times 1 is 2 minus 2 is 0. 2 times 2 is 4, 4 minus 2 is 2. Got it. What's my interval of convergence?
R is
square root. Ooh, I and 1. I and 1. Yes. That's wow. Interesting.
Well, we have to keep them real numbers. So therefore,
less than 1.
X has to be less than 1. You can't go below 0.
oh, I technically can though. Hold on, I can actually set this up.
Wouldn't it be like negative to negative 1?
We have to think of, because x squared can't actually be 1, or negative 1, right?
Can we do open interval?
But x squared could be 0.
Wait, so it's fine because it can't be negative 1, but it could be negative 0.99999, right? So it's just open interval, right?
It couldn't be anything negative.
But it can be negative, just it can't equal anything negative. You know what I mean? I'm trying to think of how to show it. So,
Negative.
if we split this up, we'd have x squared is greater than 0. I just need to split it up. X squared is greater than 1. This one's x just going to be greater than 0. This one, x is going to be greater than 1, or
Why is it greater than
Plus or minus. Yeah, it should be plus or minus.
I wrote the wrong inequality. Yeah. Less than 1. Thank you. So either x is less than 1, actually and, because less than, and x is greater than negative 1. Why? Because you have to plus or minus square root both sides, and when you put the negative plus or minus, that's going to flip the inequality for the negative portion. So what do you actually still end up with?
Doesn't the, oh yeah.
Does that make sense?
So it's still between negative 1 and 1. Unbelievable.
Oh my goodness! This is going to get exciting. Ooh, let's try this one.
Tomorrow.
But now we've gotten into a rhythm of how to actually express a power series, right? Find a power series for a rational function. White man.
Yo.
Don't worry, now it's getting exciting.
Your definition.
Hold on, George. You know where to start, though. Where do
Yeah.
we start for number 6?
Yeah. 1 over 1 minus x.
Now what's the power series for that?
1 plus x squared plus x cubed.
See, that's we. Then we need to go ahead and do 1 over 1 minus 2x. What's that going to be? Just think, who's my r?
So what do you guys like?
2x plus 4x squared plus.
We're plugging in. We're seeing who this
What are we
guy
plugging
is. We're plugging into the x spot because that's in the x spot,
Well,
like a
what are we
function
plugging in?
notation.
Like, you know what I mean? Like, how are we getting 1 and then x and then x squared and then x?
Oh, remember this is a geoseries? It's a geoseries where in this one the r was equal to x. So just think you start at 1 and then times x times x times x. And long story short, it's going to be on an Endeavor card that we're going to memorize. But remember, for geo, we have a sub 1 over 1 minus r. So we're looking at this guy in light of that guy. See it?
And then we're just multiplying.
Times x times x. Now this guy, look at him in light of him as well, because he fits the geometric series formula already as is. 1 over 1 minus 2x. I start at 1 plus, who's my r? So you can think of actually building another geometric series, or you could have just said, wait a minute, can't I just plug into this guy, because now I have a new variable of 2x and plug it in, etc.
Yeah.
Or you could say, hey, he's a geoseries, so I just say times 2x, cool, times 2x, cool, times 2x. Are we doing all right?
Yeet.
Interval of convergence we'll come back to. My nth term would be,
2x 1 to the negative minus 1.
see, could that work? 2x to the 1 minus 1 is 2x to the 0, which is 1. 2x to the 1, 2x to the 2, 2x to the 3. Yeah, that works.
Yay.
Plus dot dot dot. Interval of convergence. Who's my r?
So it would be negative 1.
Exactly.
So, hey, man.
So even though we saw that interval of convergence is, or can be frequently negative 1 to 1, you cannot use that as a rule.
If we were running out of time on the AP test and we didn't have time to figure this out,
They
we
probably didn't give you one that the interval of convergence was negative 1 to 1.
just guess and get half credit, right?
And technically right now we are only dealing with geometric power series, and so we know that it can't be at negative 1 or 1, so we keep them all open. But as we move on to power series that are not specifically with geometric functions, then possibly our interval of convergence will, the method will change a little bit as well. Let's put it that way.
Does each test have its own like peak of power series?
We're not going to go that in depth. Because geoseries, we're not specifically talking about a test for convergence per se. Per se, we're talking about the series itself. And so not all the tests correspond to a specific series, you know what I mean? So number 7. We've been doing this long enough, right? Easy cheesy.
Hey, man.
How do we build off of 1 over 1 minus x?
Do we have to write that every time?
Not specifically. Wait a minute, how do I make this guy match?
1, 4.
Start on 4.
No, but A1 goes on top though, remember?
Oh, true. Alright.
I could multiply everybody by 4.
Oh, this is that one that was. Oh, I guess not.
That's not. Is it a negative x over 4? Is it negative x?
We could do that. We could do 1 minus the negative. We already know what happens with negative, right? So couldn't we technically build off of, if we really wanted to, couldn't we have built off of 1 over 1 plus x and just had our negatives be in there?
Yeah.
We could have. Or we could build off of 1 minus x with the positives in there and then plug in. And then start at 1/4, true? Plus, now what?
Would it be negative?
Exactly, so plus a negative, so it's going to be minus. Minus what?
Maybe x equals 16. Wait.
Oh, yeah.
Why is it? Oh, right.
Does that make sense? You're plugging into him.
What's 16 times 4? 54?
You can either plug in negative x over 4, or you can think of, what's the other way of doing this?
swap a 1/4.
Can't you think of multiplying by negative x over 4?
Yeah.
So that'd be x over 16? What'd be the next one?
X squared over 64.
Next one.
X cubed over 4 cubed.
Does that make sense? What's our nth term going to be?
Um,
-1 times, right?
maybe,
Mm-hmm.
-1 times.
We do n minus 1, right?
can we do x over 4, negative x over 4 quantity to the n minus 1?
Yep, you could do that too. Interval of convergence. Who is my R?
Who's R?
Negative x over 4.
Right? Just for sake of space.
Wait,
Multiplied by 4. Multiplied by a negative. We do end up with
negative 4, 4.
nice.
Yay. Please tell me that's as funny as it gets.
It's a good foundation.
Oh. Oh, this is good.
It's a good foundation. Now, guys, technically, all these blue boxes, couldn't they be used to solve for someone else? Like, say, then we wanted 3 over 4 plus x. Maybe we should memorize 1 over 4 plus x and build off of him. That sounds like a lot of memorizing. So do you see why I keep on going back to the original function that we started with? This is a very, very, very helpful function for rational power series, or power series we're trying to find from rational functions. Technically, the other one, the 1 plus x, is another very useful. Here he is. 1 plus x is another very useful one that we can use when trying to get power series from rational functions. However, there are other very, very useful ones. We're not going to necessarily talk about them in R10-1 because this one's specifically talking about geometric series and what we can do with geometric series. But there are other important ones that are going to come, which is why we're not making an endeavor card yet. However, hopefully in doing some of this work, you're already memorizing some of these that are very important.
Are we back in our book?
Yes.
Yes. Question.
Answer. James.
How are we going to do a power series for someone that's centered not at 0?
We do the formula that we had, like, use like parentheses and x minus a.
Yeah, so we could think about how there's going to be an x minus a. And specifically, isn't r going to equal x minus a?
Yeah.
I'm saying r because this is hopefully going to match up with some sort of geometric series. Looks kind of like a geometric series, but what's it missing? The 1 minus. So 1 over 1 plus? Can I do that?
Yes. Yes, you can.
Does that make sense? I need a 1 minus, but I was like, wait, the x isn't negative. I don't want 1 minus x. I was like, I want 1 plus x, but I need to offset with minus 1. And does that get me my centered at that they needed me to find? Yes. While also identifying a new ratio. And what's my ratio now?
X minus 1.
So what is my series going to be? It's plus. I'm going to alternate signs, right? Or I can think of it as multiplying by a negative x over 1? Or negative x minus 1? How's that working out?
Seemingly fine.
Seems to work, right? what we set up was an expression for 1 over x because these are equivalent. How about my interval of convergence?
Zero to two.
Since it's a geometric series, I can see my common ratio as x minus 1. Thinking about between 1 and negative 1, I can go ahead and say, hey, x is in between 0 and 2. And doesn't that make sense? If I do have it centered at 1, it's been shifted to the right one, so all my bounds or my interval of convergence will be shifted to the right one.
What is this good for? Like,
Being able to express or deal with transcendental functions. Can I say that? Deal with non-polynomial functions in a polynomial way. How about that? Ooh, this one gets exciting. 15 over 2x minus 1, centered at x equals 1.
Can we pull 15 out to make our lives somewhat easier? And just like leave it in parentheses on the outside.
We'll just think of them as a sub 1.
Okay.
We could technically pull out a 2 if we wanted to. Centered at c equals 1, don't we need some sort of? Right? We need some sort of x minus 1. So how do we incorporate an x minus 1 into our expression?
Parentheses 2x plus 2. Because if you want to x plus 1, you just if 2x is the ratio.
So we could think of 1 minus 2 times. Is that what you're trying to do?
Yeah.
But how do we make these two match? Are they the same as is?
Not currently.
No.
Don't we need to add like a negative?
I think I need a plus, don't I? Isn't the 2x positive? Now does it match?
No. One is negative.
Careful. Same thing. Now hold on, how on earth do I get to that expression? To be honest, I'm not totally sure myself, so how could you guys get to that expression?
We have a basic formula that we have to follow and make it match.
You know, the basic formula, we're trying to make it match. We know that centered at c equals 1, we need some sort of x minus 1 to be in our common ratio. So I went ahead and was like, well, 15 is my a sub 1, I'm assuming. 1 minus, and I started to put my 2 inside, but I needed my x minus 1 on the inside. But then I'm like, wait, no, it's not 1 minus 2x, it's 1 plus 2x. And then I said, I need the minus 1, and then I said, hey, does this work? So in a sense, when they tell you centered at c equals 1, aren't they telling you a clue? In a sense, that's our clue that we know how to build our series. Now wait a minute, how are we going to use this rewritten form in order to actually get our series? Where do we start at?
15 minus. Would be
Exactly,
30.
because we have a plus, which is going to be alternating signs. Specifically, you can think, who is your r? Does that make sense? And it's going to be a negative because it's 1 minus a negative. So we can say 15 times negative 2, isn't that going to be negative 30? Plus, what's our next term going to be?
25x minus 1 squared.
Careful. Times negative 2x minus 1 times negative 2, wouldn't that be 60? Does that make sense? Then times negative 2, x minus 1 again, that'd be negative 120. So you notice I took off writing the nth term. They rarely ask you to do that, so I just kind of got annoyed with it. But interval of convergence, how would we do that?
R is 2x minus 1 negative 1/2.
Is that right? Divide by -2, flip all the inequalities.
Juan.
So x is going to be within. Right?
Juan minus 1.
I had 2.
Plus 1 is 1.5, plus 1
Can you
is.
distribute it 2 first? Maybe that. Oh, it's plus. That's okay. Oops.
that
I
right?
put something. Minus 2.
Now this is where it's really going to get exciting. We can integrate or differentiate a power series to obtain a new series. When we do this, the radius of convergence will be the same, but the interval may change. We test endpoints. We haven't talked about testing endpoints yet. So instead of saying retest, we'll say test endpoints. Wait. Why did everything just change? Why on earth are they talking about integrating and differentiating a power series? Why can't we just use what we've been doing, which is building off of like a geo series? Why is he different? It's squared on the bottom. That doesn't fit my arithmetic series, right? If we were to try to do like a 1 minus sort of thing, maybe there's another way of looking at this guy beyond looking at how we can change by, I don't know, like, changing addition to subtracting a negative or plugging in a different common ratio. Maybe there's a better way, and the better way is, hold on, how is this guy related to this guy?
He is square. Bottom is square.
AKA, if I called this guy, who would this guy be?
That's square root.
Wouldn't he be the derivative? Why is that so spiffy? Well, hold on. If he's the derivative, and if this just says you can integrate or differentiate power series, then can't we say that this guy is equal to the derivative of this guy, which means we want to derive this guy's and what is that derivative going to be?
0 plus 1 plus 2x plus 3x squared plus.
That's cool.
So not all power series are necessarily formed by just
Then what's R?
manipulating what we have.
Is R still 1 minus x squared? Or is it?
Not a geometric series anymore.
So then, can we find that?
It's the derivative of a geometric series, but is no longer a geometric series. So how are we going to do the interval of convergence? Wait, when we derive or when we integrate, it stays the same, but we have to test the endpoints. What does that mean? What that means is, what was the original interval of convergence? For 1 over 1 minus x, we had that x is between -1 and 1, right? So in order to do our interval of convergence for this one, we are going to go ahead and keep the x, we're going to keep the 1, we're going to keep the -1, but we're going to test, wait, what? We're going to test the endpoints. How? We're going to say at x equals -1. We're going to say at x equals +1. Wait, at? What's going on? I don't understand. Hold on. What series is this guy? Wait, what series is this guy? Yeah. What series is this guy? Stink. Why were they having us test or find nth terms? We need to think about what series he comes from. How could we express this as a series?
N plus 1 times x.
Close, except what's the next term going to be? Isn't it going to be 12?
So we,
Oh, I didn't put 4. Sorry. Whoa. No, I did that right.
it is 0.
You are right.
It's 0.
Because it's 1, then 2, then 3, then 4 times x to the what?
N plus 1?
Close.
Uh,
And minus 1, right? So wait a minute, what's going on at x equals -1? What series am I actually looking at? Well, we plug it in and we say, okay, from n equals 1 to infinity of n times, what if x was literally -1? Oh my goodness, we have to think about our convergence and divergence tests. And then what's going on at +1? Oh my goodness, we're going to have to think about our convergence and divergence tests.
That doesn't sound pleasing. Pleasant for that matter.
Pleasant or pleasing, pleasing or pleasant. But can't you look at it quickly and say, wait a minute, isn't the left one an alternating series, and what's the limit as n goes to infinity? Yeah, so therefore it's not 0, so doesn't this one diverge by the alternating series test?
Yes.
How about the one on the right? Well, 1 times 1 times 1 is still 1, yeah? So what's the limit as n goes to infinity of the right one? This one diverges by the alternating series test. This one diverges by the nth term test. So question, is it allowed to be at 1 or at -1? And the answer is no. So this one fails. That one fails. This one fails. So what are my inequalities? That's not allowed to be. Yeah, there you go. There you go. So when you use this integrating differentiation, it's frozen. Let it go. Oh no, it's back. When you use the differentiation or integration technique in order to be able to find power series based on other ones that you know, be careful with the interval of convergence. Now kiddos, in homework, it is not super long per se, and I've given you a lot of odds because it requires some creative thinking. But fully attempt it for tomorrow. Come in with questions. We're going to actually go over questions first, and then we'll start on 10-2. Might do a couple more examples that are strategic to what's at hand, or they might just be homework questions. Bye, cool kids. Yeah.